back to KimikApp. I'm Erica Escartes, and today we're diving into Avogadro's number, an incredible tool for converting between moles and particles like atoms or molecules. If you ever wondered how many particles makes up a substance, you're in the right place. Let's explore how to use Avogadro's number in particle calculations. Using Avogadro's number in particle calculations. Now, when we talk about particles like atoms or molecules, we use Avogadro's number, which is 6.022 times 10 raised to the 23rd particles per mole. These numbers allows us to convert between the number of particles and the number of moles. For example, if you have 1 mole of carbon atoms, how many atoms do you have? We have here our problem. Find the number of atoms in 1 mole of carbon. Step 1 is to list the known quantities and plan the problem. The known quantities are the number of moles, 1 mole of carbon atom, and the Avogadro's number, which is 6.022 times 10 raised to the 23rd particles per mole. The unknown is the number of carbon atoms, and this is what we are solving for. Then to plan, we use the formula for mole to particle conversion, which is number of particles is equal to moles times 6.022 times 10 raised to the 23rd. Then we substitute the values for the moles of carbon and Avogadro's number. Let's proceed to step 2, calculate. Number of particles is equal to 1 mole times 6.022 times 10 raised to the 23rd atoms per mole. The number of particles is equal to 6.022 times 10 raised to the 23rd atoms. Finally, step 3, think about your result. Since each mole of carbon contains 6.022 times 10 raised to the 23rd atoms, multiplying by 1 gives 6.022 times 10 raised to the 23rd carbon atoms. Therefore, 1 mole of carbon atoms contains 6.022 times 10 raised to the 23rd atoms. Another example. Let's say you have 2 moles of sodium atoms. How many atoms do you have? The problem is find the number of atoms in 2 moles of sodium. Step 1. List the known quantities and plan the problem. The known quantities are the number of moles, which is 2 moles of sodium atoms, and the Avogadro's number, which is 6.022 times 10 raised to the 23rd particles per mole. The unknown is the number of sodium atoms, and this is what we are solving for. Then for our plan, use the formula for mole to particle conversion, which is the number of particles is equal to moles times 6.022 times 10 raised to the 23rd. Then, we substitute the values for the moles of sodium and Avogadro's number. Let's proceed to step 2. Calculate. Number of particles is equal to 2 moles times 6.022 times 10 raised to the 23rd atoms per mole. Then we have the number of particles is equal to 1.204 times 10 raised to the 24th atoms. Finally, think about your result. Since each mole of sodium contains 6.022 times 10 raised to the 23rd atoms, multiplying by 2 gives 1.204 times 10 raised to the 24th sodium atoms. Therefore, 2 moles of sodium contains 1.204 times 10 raised to the 24th atoms. That wraps up our discussion on Avogadro's number and particle calculations. I hope you found this tutorial helpful in making these big numbers easier to work with. Don't forget to like and subscribe to KimikApp, and feel free to share your questions in the comments. Thanks for watching, and keep pushing your chemistry skills forward. Bye everyone!